All right, guys, keeping in mind what we just said about the complement thing, find the probability that the sum is not 7. Well, earlier we found the probability that the sum is 7 is 1/6. So we already know that. So the probability that it's not 7 is going to be 1 minus the probability that the sum is 7. So that's just 1 minus 1/6. It's 5/6. Now, if I didn't use that complement rule, I would be sitting here all day counting things that don't add up to 7 and trying to add them up. And I guarantee you I would lose track at least once because, let's be honest, I'm not that smart. Definition number 3. From the basic probability rules, number 3 from number 3. Honestly, you need another teacher. Number 3 from the basic rules, it describes the complement. The notation goes like this. The probability of a complement. That notation, that little C up there, is like use the word not in front of the event. I want the probability that it's not equal to 7, right? That's equal to 1 minus the probability of A. And so underneath, I'll just put probability of not A is equal to 1 minus the probability of A. Okay, that's how that goes. There's your notation. 272 in the book, we're going to talk about, through an example where they open up a whole bunch of bags of M&Ms. Suppose you tear open the corner of a bag of M&M's milk chocolate candies, and you pour one candy into your hand and observe the color. According to Mars Incorporated, they're the makers of M&M's. The probability model is they are not all equally likely to come out. I think we've talked about this before, but the reason they go with that particular distribution of colors is because that picture is the one most likely to make you want to go buy M&M's. It's an advertising trick. Part A, explain why this is a valid probability model. You definitely will be asked this question on your homework and on your test. It's kind of like the question you had on the last one that said, is this a valid statistics question? It's a two-parter. Are all of the probabilities in between 0 and 1? Yes, they are. And do they add up to 1? And somebody went down here and did all the work. Yes, they do. Part B, find the probability that you don't get a blue M&M. Look, you got two choices for that. If you want anything that's not blue, you can go add up all 5 of these, or you could just simply go, well, the only way to get something that's, listen to this, not blue, is to get something that is blue. So I'm going to go 1 minus 0.24. 1 minus 0.24 is 0.76. There it is right there. And if you add these up, you will get 0.76. All right, there's another example of using the complement rule. Using the probability model from that page, find the probability of blue or green. Okay, I'm going somewhere with this. You definitely can't get an M&M that's both blue and green unless something funny happened at the factory. So, blue or green. What's the probability of getting something blue? 0.24. What's the probability of getting one of these that's green? 0.16. What's the probability of getting some blue or green? Isn't it almost common sense to you that we just add these two up? 0.24 and 0.16, and we get 0.4. So we're going to write this down just so that you see it. You could look back at the book. 0.24 plus 0.16 is equal to 0.40. All right? It's only the case that you can add probabilities like I just did when they don't have anything in common. If they do share some kind of an event in common, you're not allowed to just add them together. And I will explain why either in this example or within the next day or two. All right, but I'm going to give a definition for what that means in the first place. You may have heard this phrase before. Two events are mutually exclusive. As statistics has become more and more popular as something you use, and it's used in more college classes, people are starting to use the terminology of our discipline in common language. So you may have heard somebody say, hey, those things are not mutually exclusive. This is the meaning of it. There's another word that describes it. It's called disjoint. Mutually exclusive and disjoint mean the same thing. It means they have no events in common, so that the probability of A and B happening, the probability they both happen at the same time, is definitely 0. Okay? So here's, I'm saying this is your first probability formula, but that's kind of a lie, isn't it? This is really your second probability. In fact, let's fix the lie before we get called out. If two events are mutually exclusive, They don't have anything in common. The additional rule for probabilities goes: probability of A or B, just like blue or green a moment ago, is equal to the probability of A plus the probability of B. I'm allowed to just straight up add the probabilities as long as they don't have anything in common. Okay, let's go to page 273 and close this set of notes out here. Is it easy to pass the AP exam? Randomly select a student who took the 2015 AP Statistics exam and record the student's score. Here's the probability model according to the College Board. It looks like the most common numbers that people got, it's a score out of 5. 3 out of 5, that was a quarter of the people, and then 1 out of 5, that's a failure. These two are failures right here. These are the people that passed the test. Many people consider scores 3, 4, or 5 as passing scores because many colleges award credit or placement to students who earn these scores. Pretty sure I just said that. Part A, find the probability that the chosen student scored less than a 3. That means you didn't make it. The college is not going to give you credit for it. Since these can't happen at the same time, people get scores back. You get a 1 or a 2. You don't get both. You're allowed to just add them together. So here we go. Scored less than a 3 means they scored 1 or 2. That word or is really important to us this chapter. So we're going to add together. They scored a 1. They scored a 2. There's the 2 together. Add this and this. You get 0.422. Now, you guys, it's not as simple as, hey, look, I added 2 numbers together. I want you following through the thought process and the formulas. You spend a little more time with this. Trust me, I've taught it many years, and I know how people make mistakes. And if you get lazy and too quick and just go, oh, look, I added 2 numbers, I'm an expert, you're going to find yourself in trouble. All right, part B, the probability that the chosen student earned a passing score. Okay, there's 3 ways that could happen. You get a 3 or a 4 or a 5. And those are all mutually exclusive. They can't possibly happen at the same time. You get one or the other here. And so I take that, and I just add them. So I would get this, just put them in the calculator. But look what they do for part B here. Since we've already done some other work, isn't it the case that it's 1 minus the sum I just got? Like, look, I just found out that there's a 0.422 or a 42.2% chance that I fail it. Well, I'm really now asking what's the probability that I pass it. It's just 1 minus this. So I go 1 minus 0.422, and I get 0.578, which is exactly what you would get if you added those 3 numbers together. All right, and I think that's what they show down here. If you add the 3 numbers together, you get the exact same thing. Okay, that's your notes for today, people. Your homework is on page 274 to 276, 1 through 13 odd. I will make sure that the answers are posted so you can see how you did. Do your homework, people. We only got a few days left before the end of this chapter and before we get to break, so stay on top of your stuff, do your homework. Have a good day.